Okay, welcome back everybody. So you've got the sheet from the Monday-Tuesday class. Okay, and we started with this idea of SOH CAH TOA, and we saw these curves, and we saw these animations on the screen, and these right triangles. Okay, as one gets bigger, one gets smaller. There's a dance and a relationship. Okay, and this is how we describe the world. Tides, motions, mathematically. Alright, first thing I want to do today, we're going to pause this video and we want to have a share out. Did anybody come up with a mnemonic, a rhyme, a song, a rap? Okay? I'm serious. You come up with one of those, it's an A for the month. Okay? Those other guys down the hall, they're going to do SOH CAH TOA for a month. If we get this down, we don't have to do this for the entire month. SOH CAH TOA, this relationship, this way of describing the world mathematically. Anybody? Pause the video. Alright, welcome back. Hopefully, normally, we end up with 3 or 4 versions of SOH CAH TOA. Alright? So hopefully you shared them out. Hopefully one of them kind of sticks with you so that we can use it. Okay. So the other day when we were together, we finished this page. No, all we got was the first one, right? Yep. Trigonometric ratios. And then we did a couple on the second page. So today we could either finish those, or I think the best thing to do is do a warm-up today. Whoop, what the heck? Oh. Okay, our Wednesday, Thursday warm-up, okay? I want to use, uh-oh, that was weird. I don't know what happened. Okay, let's do this, okay. Now, one of the problems here with today's warm-up is I don't have all the information. I'm missing this. Okay? And I don't want us to ever forget how to calculate the hypotenuse, the HYP. Across from the 90 degree is the HYP, okay, the hypotenuse. And we want to make sure that we remember the Pythagorean theorem. So we're going to start class today by doing the Pythagorean theorem. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Alright? Now, 1 squared plus 2.4 squared is equal to the hypotenuse squared. Okay? Now I want you to pause the video, and I'd like everybody to go do that math. Okay? And each one of these has a little bit of a twist. They got some decimal points in there. Okay, give it a try. Alright, spoiler alert, here we go. 1 times 1 is 1, and 2.4 times 2.4. I'm going to grab my Webbit. You ever notice how my head's always in the way? Okay, 2.4 squared. Okay, 5.76 equals the hypotenuse squared. 6.76 equals the hypotenuse squared. And don't ever forget, how do we undo a squared? We take the square root of both sides. So you could leave square root of 6.76, or remember, the opposite of squared is square root. So we're just going to go second square root 6.76. And, oh, that's so cool, 2.6. It's perfect. 2.6 is the hypotenuse. 2.6. Okay? What did you get on the second one? All right. Now, a couple of you were like, what in the heck is that? Okay? So, 2 radical 3 squared is nothing more than 2 radical 3 times 2 radical 3, right? Whenever you have something squared, it's just itself times itself, right? 2 squared is nothing more than 2 times 2. All right, let's do the math. Let's try to do it in our heads here. 2 times 2 is 4. Square root of 3 times the square root of 3 is the square root of 9. What's the square root of 9? 3. So this gives us 4 times 3, which is 12. Okay? Now let's grab a calculator and test this. Monty said, parenthesis, 2, square root 3, close parenthesis. Oop, didn't want that. Okay, everybody practice typing. Okay, get your Webbit out. Use parentheses. That way we know exactly what is squared. Then I'm going to hit the caret key, squared. Boom. 12. We got the same answer. Watch this again. 2 square root 3 toggle squared. Didn't work. Okay? Make sure when you're using the calculator, we use parentheses so that it knows exactly what we're squaring. Now hit the squared button. Good. Okay, so it's 12. Alright. So now this became a 12. 2 times 2 is 4. Hypotenuse squared. 16 is the hypotenuse squared. We know the opposite of squared is the square root. To undo a squared is to take the square root. So in this case, we get 4 is the hypotenuse. All right. Now, one of the processes, there's math at its best. If you have to, pause the video. Make sure you have this down on your note page. Okay? All right. And here we go. Okay, as a group, we want to chant this. Calculate the trigonometric ratio for B. B. First thing you want to do, circle it, the REF, okay, the OPP, the ADJ, and the HYP. Now, when I say chant, it says tan. SOH CAH TOA. The tangent of B is equal to what? The what over the what? What's O? What's A? Oscar has a heap of apples. The OPP over the ADJ. So in this case, the tangent of B is equal to 2 over 2. Okay? Yes, you can write the tangent of B is equal to 1 over 1. Absolutely you can. Okay? But we want it to be a fraction because they have meaning. Okay? The something over the something. We always want to have a fraction. Okay? Alright, let's chant the tangent. The tangent of the angle. The first thing we want is the reference angle. We want the OPP. We want the ADJ. And we want the HYP. So the tangent of C. SOH CAH TOA. The opposite over the adjacent. The OPP over the ADJ. The tangent of C is equal to 25 over 20. Okay? Again, That's a correct answer. Simplify. Pause the video if you need to chat about it. 5 times 5, 5 times 4. I'm going to simplify by a factor of 5, leaving me with 5 over 4 is a better answer. Okay, 25 over 20 is not wrong, just 5 over 4 is better. Alright? Okay, let's do it again. The tangent, TOA. The TOA. Okay, the first thing is circle the reference angle, the OPP, the HYP, and the ADJ, and the TOA. The tangent of letter D, angle D, is the OPP over the ADJ. The tangent of D is 2 radical 2 over 15. Okay? There's no way to simplify the 2 and the 15. Good to go. Alright. As a group, we're going to chant on Wednesday and Thursday. Here we go. The sine, SOH CAH TOA. SOH CAH TOA. Sine is the Oscar has, the opposite over the hypotenuse. Alright? So here we go. Opposite over hypotenuse. Oh, we got to label again. The reference, the OPP, the HYP. So the sine of B is 3 radical 3 over 6. Can you see how 3 over 6 can be simplified to 1 over 2? 1 radical 3 over 2. You don't have to have the 1. I like the 1 because it has meaning. Alright, and I think we got one more is all. Nope. Yeah, we had 2 here, didn't we? And then, oh, we got a couple more. Okay, so let's do it again. Sine. So, here's our reference. There's our OPP. There's our HYP. That would be our ADJ. So the sine of C is 25 over 35. Cool. Again, pause the video for when it comes to simplification. Spoiler alert! 5 times 5, 5 times 7. I'm going to get a factor of 5 out of there, leaving me with 5 over 7. Okay? And I think the only one we haven't done is cos, the cosine. Ca. Oops. Ca, not can. I can do it. So, CAH TOA. The cosine is the adjacent over hypotenuse. So now we have our reference, we have our adjacent, across is the hypotenuse, because over here is the OPP. So the adjacent over the hypotenuse, the adjacent is 3 radical 3 over 6. Again, 3 and 6 can be canceled to 1 and 2. 1 radical 3 over 2 if you want radical 3 over 2. Okay? And our last one, no, we got a couple more. We're good. Cosine. Here's our reference. We knew that because they're saying the cosine of the reference angle C. So here's our OPP. Here's our HYP. And here's our ADJ. Alright, so the cosine of angle C is 25 over 35. And you may remember that from the previous page. 5 times 5, 5 times 7. 5 over 7. All right. So now, as a class, you can go on and do more of these. But we have our solo at-home learning activity where you do some SOH CAH TOA. All right? Okay, so let's go back here. And I think there was one more. Nope. Okay. Yes, that's right. Okay. Once we get to this point, I wanted to make sure that we all logged in because in Mathia we've moved forward. All right? And in Mathia, we want to practice this vocabulary. So let's take a minute here and make sure that we know how to find Mathia. So we're going to go to Spokane Public Schools. And from Spokane Public Schools, we've got to find our digital tools. We've got to find Clever. We've got to log in. It's our email address. And we want to find Carnegie Learning. Boom. Okay. Now, as a class, we've moved everybody forward to the trigonometry part. So we're going to click on our Mathia button, and for this class, I think we're here. Now, you're going to see special right triangles in trigonometry. I've moved everybody to trigonometric ratios, and this week is all about vocabulary. Introduction to trigonometric ratios. Okay? So let's see if we can do the first couple problems together. Okay, similar figures. Let's go to angle A. Ooh, the adjacent. I know where that is. The opposite. I know where that is. And this idea of the reference angle. That's what we've been doing in class. Okay? So let's go here, and they're talking about the ratio. Just because it looks confusing, all they're saying is DC, since DC over EB. DC, EB. Okay, we're talking about ratios. SOH CAH TOA. Okay? Use the reference angle in the diagram. The measure of angle P is 60. Select the segment which represents the opposite, the reference angle. Okay? The sine ratio. The sine. SOH CAH TOA. And this is where I want you to have your reference sheet out. Okay? And let's just grab our reference sheet. Our cheat sheet. Boom. So here's our cheat sheet. Alright? So, opposite over hypotenuse. Okay, my head's in the way again. The opposite, sine P, 5196. 51.96, enter. Opposite over hypotenuse. Okay? 60. Done. Sine of angle P. Sine of angle P. What are we doing here? Then enter the sine of the angle. 51.96 divided by 60. That's all it is. Just typed in that relationship. Done. Okay? The sine of angle P above tells us the length of side QR is 0.866%. Okay? Now let's see what happens if I just type in 0.866. Doesn't work. Okay? Do you guys know how to convert from decimals to percent? 86.6. Alright, so Mr. Miller is going to take a minute and introduce the idea of percents. Alright, so unfortunately our fancy calculators don't have a percent key. Alright, if you'll notice, this $100 calculator here does not have a percent button. Isn't that goofy? Let's see if the handheld calculator has a percent key. The calculator on our standard. Percent key. Can you believe it? There's a percent key. So let's see if I go 86.6%. Oh, how does that work, right? What is 10% of 100? Okay, so you see how everything's got a learning curve? How does that happen, right? So we're going to have to spend some time and learn how to do percents, because I don't think everybody does. So how many cents in a dollar? Percent. Percent. How many cents in a dollar? $100 pennies. So now, if I have 86 pennies per 100, 86 per 100, I get 86, I get 0.86. Grab our calculator, 86 divided by 100, 86%. So now, if we take a number, percent. Now I had the number 0.866. So if we divide to get the decimal, we have to multiply to get the percent. So now I'll take 0.866 times 100, 86.6%. All right. So, a little sidetrack there. One of the things about Mathia is all of a sudden it just pops something in like that, right? So let's go and hit undone. We'll do one more and we're going to call it a day. All right. So the reference angle, 18. Select the segment that represents adjacent. Angle P. There's our adjacent. So it's going to be 114.13. Enter. Okay. Over the hypotenuse, 120. Okay, cosine is just 114.13 slash 120. Okay, now percent. In order to get percent, we take the 0.951 and we multiply by 100 to get 95.1. Okay? 95.1%. So, in a class, you guys can work together, move the decimal point over twice. All right? Thanks for coming. Welcome back. Hopefully we're getting back into the swing of school. Have a great week. For those of you coming on Friday, we got to do a couple more puzzles and maybe some calculator activities like this one. Bye-bye.